Hey YouTube, thanks for visiting. This is Chandan and in this video we are going to solve some questions of WBCSC statistics, okay, and WBCSC 2020 paper, okay. So we already solved some questions of statistics portion from 2022 paper of WBCSC, okay, and in this session we are going to solve some questions of WBCSC 2020 portion, okay. So let's start to solve, and those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and don't forget to subscribe the channel, okay. And you will get the 2022 mathematics papers portion and the statistics papers portion in the playlist of WBCSC mathematical science, okay. And one more thing is that these questions we covered in these sessions are very helpful for CSIR NET also, okay, because these questions of statistics are very conceptual, okay. So that's why you can also practice these questions for the CSIR NET exam also, okay. So this is our first question, and this is the questions paper of X series, okay. So X series question number 67 from statistics. It says that consider the finite population U equal to 1 to 3 with P 1 2 this is equal to half, P 1 3 this is equal to 1 by 4, and P 2 3 this is equal to 1 by 4. Then which of the following option is not true, okay. And here the four options are including the number pi, okay. So what is the pi? Pi k is the first order inclusion probability in of the kth unit, okay. So these questions is from the chapter sampling, okay. Just a second. This question is from sampling and the questions is based on inclusion probability, okay. Now what is the inclusion probability? First we define what is the inclusion probability. The probability, okay, that the unit k, okay, is included in the samples, okay. Here there are three samples. This is one sample, this is two sample, and this is three sample, okay. And k means here, so we first calculate the pi 1, pi 2 and pi 3. So pi 1 this is equal to what? Since pi 1 is included in the sample first and sample 2, this 1 is included in the, that is the ith unit, okay. This unit 1 is included in the first and second probabilities, therefore we take sum of these two probabilities. So probability of what? 1 and 2 plus probability of what? 1 and 3, okay. Since this 1 and this one are included in these two samples, okay. So this is equal to what? 1 by 2 plus 1 by 4, this is equal to 3 by 4. Similarly pi 2 equal to, we take the samples in which this 2 is included, okay. So this is equal to probability of 1 and 2 plus probability of what? This third sample 2 and 3, okay. So this is equal to 1 by 2 plus 1 by 4 again, so this is equal to 3 by 4, okay. Then pi 3 equal to what? Pi 3 equal to probability of, so this is equal to 1 3 plus probability of 2 and 3, okay. So the probabilities corresponding to that, this 3 sample or this unit 3 is included in these samples, okay. So this is equal to 1 by 4 plus 1 by 4, which is equal to 1 by 2. Therefore it says that which of the following is not true, okay. So pi 1 equal to 4, yes, pi 1 equal to 4, this is correct. Pi 2 equal to 3 by 4, yes, this is also correct. Now pi 1 plus pi 2 plus pi 3, this is equal to what? 3 by 4 plus 3 by 4 plus 1 by 2, which is equal to 6 8 by 4, which is equal to 2, okay. That means what? Here the D option is also correct, therefore the incorrect option is this one, therefore our answer is option C here. C is the not true statement, okay. I think this is you can understand the concept and the questions. Okay, now going to the next question. This question number 70 is again from linear model. Okay, so I already solved a questions of linear model in 2022 section. This is the same question. The question says that suppose expectation of y1 equal to expectation of y2 equal to beta, variance of y1 equal to 5 sigma square, variance of y2 equal to 2 sigma square. Then covariance of y1 and y2 is equal to sigma square. And in the questions paper of 2022, it is given that the y1 and y2 are independent. That's why in that case the covariance term equal to 0. Okay, so to solve this question, then which of the following is blue? We all know that what is the full form of blue. So based, linear, unbiased estimator. Okay, based, linear, unbiased estimator. Now we have to first find which of the following or which of the given estimators are unbiased estimator. That is, expectation of that estimator is again the beta. Okay, and based linear means with minimum variance. So unbiased, we already said that unbiased plus minimum variance, this is equal to blue. Okay, now we first see whether these four estimator are unbiased estimator or not, and then find the variances. Okay, so if we calculate expectation of y1 plus y2 by 2, this is equal to 1 by 2. Since this is linear or satisfies the linearity property, we can write expectation of y1 plus expectation of y2, and this is simply 1 by 2 into beta plus beta, which is equal to beta. That means this is unbiased. Similarly, if we can check this and this, you can easily see that these four options all are the estimators are unbiased estimators. Okay, so now we have to calculate or we have to find the minimum variance. Okay, so we first calculate or we calculate the variances of the corresponding options. Okay, so expectation of y1 plus y2 by 2, and here one thing is needed, which is the formula of covariances. So covariance of ax plus by for any two random variable x and y, this is equal to a square variance of x plus b square, or this is plus minus you can use, covariance of y plus minus 2. If there is plus, then there is plus. Okay, covariance of, sorry, this is the variance now, variance of ax plus minus by, this is equal to covariance of x and y. Okay, this formula we need because here covariance terms is present in between y1 and y2. So this is equal to 1 by 4, sorry, this is, we find the variance of this is equal to 1 by 4 variance of y1 plus 1 by 4, since a and b value is here 1 by 2 and 1 by 2, variance of y2 plus 2 into 1 by 2 into 1 by 2, covariance of y1 and y2. Okay, covariance of y1 and y2. So this is equal to 1 by 4 into variance of y1 means given 5 sigma square. So 5 sigma square plus 1 by 4 into variance of y2 is 2 sigma square plus this cancelled 1 by 2 into covariance of y1 and y2 means simply sigma square. Okay, so this is equal to 5 by 4. If we take common 1 by 4, then 1 by 4 into 5 plus 2 plus 2 and sigma square. So this is equal to 9 by 4 sigma square. Okay, so this is equal to, I think, 2.2 and 5 sigma square. Okay, now if we calculate the second part, then we can see, just a minute, for the second option B, for option B we calculate. Okay, so variance of y1 plus y1 by 5 plus y2 by 2 by 1 by 5 plus 1 by 2. So this is a big term. Okay, so this is equal to, we can simply write variance of y1 by 3.5, you can get 3.5, and plus y2 by, after this calculation, 1.4. okay, so this is equal to what, 1 by 3.5 square variance of y1 plus 1 by 1.4 square variance of y2 plus 2 into 1 by 3.5 into 1.4 2ab curve of y1 and y2, and after putting these values and calculation, we get this value equal to 4.73 sigma square. Okay, now we calculate the C and D, the variance of option C and D. So variance of 2y1 plus 3y2 by 5, this is equal to what, 4 by 25 variance of y1 plus 9 by 25 variance of y2 plus 2 into 2 by 5 into 3 by 5 covariance of y1 and y2. So this is equal to 4 by 25 variance of y1 means 5 sigma square plus 9 by 25 variance of y2 means what, this is 2 sigma square plus 4 3s are 12 by 25, covariance means simply sigma square. Okay, so 20 plus 18, 38 plus 12, so 50 by 25 sigma square. Okay, so this implies 2 sigma square. This is the option B, sorry C, this is option C. Now if we calculate the variance of the fourth term, this is equal to y1 plus 4y2. So variance of y1 plus 4y2 by 5, I think this is 5, yes 5. So this is equal to 1 by 25 variance of y1 plus 16 by 25 variance of y2 plus 2 into 1 by 5 into 4 by 5 covariance of y1 and y2. So this is equal to 1 by 25 variance of y1 means 5 sigma square, 16 by 25 variance of y2 means 2 sigma square plus 8 by 25 sigma square. So this gives 16 to the 32, 40 and 45. So 45 by 25 sigma square, and which is, this is equal to what, 0.9 sigma square. Okay, so we find all the variances, and this is the minimum variance among all the given estimator. So that means our answer is option D here. Okay, this is the blue, that is best linear unbiased estimator. Going to the next question. This question is based on what, sampling survey, I think. Okay, so this is from sampling again. I think I write all the questions. This is from linear model, this is yes from sampling. This is sampling or design theory, forget that. So skip that part. Okay, so this is very easy question if you know the one line statement. Okay, which is sample mean is unbiased estimator of population mean. But sample variance is not. So this is one line statement. If you know this statement, this question is 1 second question. Okay, so based on this statement, a question comes in CSIR NET November 2020. Okay, 4.75 marks में आता है question. ठीक है, one question comes in this paper. Okay, so this is clearly mu bar. This is the sample mean, I think. maximum likelihood estimator, and since this is the samples, so this is unbiased for mu, but this sigma is not unbiased for this sigma. This is a mean and this is the variances. Okay, so option B is clearly correct here. Now going to the next statement. So question number 84 says that if x1, x2, x3, x4 independent normal 0, 1 random variables, then the distribution of x1, x2 minus x3, x4. This is again you can show a note type question. If you know the statement, then you can solve these questions, otherwise you can't solve the question. Okay, so we all know that if x1, if x follows standard normal 0, 1 variate, then what x square follows what chi-square distribution 1 degrees of freedom. Okay, so here x1, x2 means, so here again x1, x2, this is again follows chi-square distribution 1 with 1 degrees of freedom. Similarly, square of standard normal variates, or since these are independent, therefore we can multiply this. So this form again x3, x4 is again follows chi-square distribution with 1 degrees of freedom, but their differences chi-square, if x follows chi-square m, now there is differences, x follows chi-square m and y follows chi-square n variate, and n not equal to n or m greater than n, you can say m greater than n, then x minus y follows chi-square distribution with m minus n degrees of freedom. But here in both these two distributions, the variance the what degrees of freedom is same, that's why this is not the chi-square distribution. Okay, if in this case, okay, or if this happens, then you can remind this follows always Laplace distribution. There are some special notes, okay, special notes on these types of distributions or relation between the two distributions or sampling distribution. Okay, so you can always remind that if this given, then it follows Laplace distribution, not logistic, not Cauchy, not normal. Okay, going to the next question, question number 85. It says that if rho xy is the correlation between x and y, then the correlation between u and v, we have to find the correlation between u and v. So we first write what is the formula, correlation coefficient between u and v, this is equal to covariance of u and v by what, sigma u, that is standard deviation of u into standard deviation of v. So we have to find these quantities. Now to calculate these quantities, we need two relation. One is covariance of ax plus b, and cx plus d, this is equal to ac variance of x, sorry, ac covariance of x and y. Cu, sorry, this is cy. So ac covariance of x and y. So here given u equal to x, a plus cx, so u equal to a plus cx and v equal to b minus dy. Therefore covariance of u and v, this is equal to covariance of a plus cx and b minus dy. So using this relation, this is the standard relation, we get this is equal to minus of cd, okay, covariance of what, x and y. Okay, so we can write this, and yes, this one. Okay, now we find the sigma u. So sigma of u, we find the variances. So since square root of variances is standard deviation of variation of u, this is equal to variance of a plus cx, and we all know that this is equal to c square variance of x. Okay, so this is equal to, we write c square sigma x square, but sigma x is the standard deviation. Okay, similarly variance of v, this is equal to what, variance of this one, b minus dy, b minus dy. Okay, so this question is based on this chapter correlation coefficient. Okay, so this is equal to d square variance of y, which is equal to, we can write d square sigma x sigma y square. Okay, this is this form. Now this implies what? Sigma u, this is equal to C sigma x. Since here A, B, C, D all are greater than 0, therefore square root of C, here we take simple C. Otherwise, in general, we obviously take the modulus form of this. If this A, B, C, D are not given, whether it is greater than 0 or less than 0. Okay, in that case, or if this condition is not provided in the question, then we take the modulus. Okay, but in this case, since it is provided that A, B, C, D are all greater than 0, then we take simply positive square root. And here also we get what? This is equal to sigma square u you can take, and this is equal to sigma square v you can take. So sigma v, this is equal to d sigma y. Okay, this. So we put just the values in the given formula. So from the given formula we get what? Rho of u v, this is equal to what? Cob of u v, means this one, minus cd cob of x and y by what? C sigma x and d sigma y. Okay, so this is equal to what? CD going to cancel, so this is minus cob of x y by sigma x into sigma y, and this is the simple definition of correlation, which is equal to minus into correlation coefficient between x and y. So this is the answer, which is clear option D. Okay, this is the question and this is the answer. Now question number 88, this question is from characteristic function. Okay, so which of the following is not characteristic function? Whether you have to check whether a given function is characteristic function or not, you always remind three properties of characteristic function. Okay, one is phi of 0, this is equal to 1. Number 2 is what? Mod of phi t or phi x, this is always less equal to 1, which is equal to phi 0. And number 3 is this phi t is uniform continuous, uniformly continuous in t. Okay, in this variable t. Okay, now we check whether these three or these four given functions satisfies these three properties or not. If we put the values 0 at t, so 1 by cos, this all four functions gives the value 1. Okay, therefore we can't conclude in by this property 1. Now by property 2, mod of phi dash t is less than 1 for all t. Okay, now for all t, since the range of cos hyperbolic t range is 1 and infinity, therefore 1 by cos hyperbolic t must less equal to 1. Okay, similarly, and we all know that mod of cos function is less equal to 1, and in this case these two are remaining. Now this is bounded for all t. Okay, now if we put the value here t equal to what? Pi by 4, then what happens? This 2 by 1 plus cos phi by 4 means 1 by 2. This is equal to 2 by 3 by 2. So this is equal to 4 by 3, which is greater than 1, not less than 1. That means this is not bounded in one value of t. Therefore this is not a characteristic function. We can obviously conclude this. Or you can also check by this property, phi t is not uniformly continuous in t. Now at t equal to pi, you can take, if we take t equal to pi, then cos pi equal to minus 1, and this gives 2 by 1 minus 1. This is not existence. Okay, this function has no existence at t equal to pi. Therefore this is not the uniformly continuous. On that point, that means we can also conclude by this property. Okay, so here option C is not the characteristic function. Okay, I think this is understandable. Okay, going to the next question and last question for today's session, which is this question is again from reliability theory. and I recommend that you must watch the class on reliability theory of which is available in my channel. Okay, so then you get the concept of these questions or according to the reliability theory. Okay, so a question says that a 3-unit parallel system has independent components with reliability 0.2, 0.3 and 0.4 respectively. Then the reliability of the system is, so this is says that a parallel system, that means this type of function. This is the parallel system, we all know that this is the parallel system. Suppose this is reliability function 0.2, 0.3 and 0.4. Now what is the system reliability of the function? So reliability of the system RS, suppose if we write reliability of the system, this is equal to 1 minus product of 1 minus RIT. This is the formula here, I equal to 1 to 3, since there are 3 independent components, and RIT is the reliability of each component. Okay, so this is equal to 1 minus 0.2 into 1 minus 0.3 into 1 minus 0.4. This is equal to 1 minus 0.8 into 0.7 into 0.6. This is equal to 1 minus 0.336. This is equal to 0.664. Okay, so this is the answer of this question, option number C. So this is the last question. Yes, so this is the last question for today's session. If this session is helpful, then please give a like to this video, share with your friends and subscribe the channel. Thank you friends, see you again in the next video. Thank you.